Hello, this is a video demo of BC188 Throughput UART over TCP, transparent. Today we're going to test the maximum throughput we get, and in order to do this we start as usual by connecting the module, restarting it, opening a UART connection with the default settings, which in our case are 9600 baud rate and no flow control. So as we can see, the module is now started, but in order to achieve higher throughput we would need to change the baud rate. So let's do that. In order to do that we need to set the baud rate to something higher, and the maximum we support at the moment is 2 megabits per second, so this is 2 million bits per second. So we set this configuration, and then we also need to enable flow control and hardware flow control so that we're sure that the data is sent correctly and received correctly. So we set this setting, and then we do config save which saves the new values, and then we can just go and reset the module. In order to reconnect, of course, we need to change the baud rate of the program we're using. So we don't have this by default in this drop-down list, so we need to type this in. So 2 million, and then we enable the hardware flow control. We press OK, and we can see that the output of Melody is now presented on the screen. So right now we configured Melody to talk over a UART baud rate of 2 megabits per second. The next thing we want to do is connect our module to an access point, and again we need to set a few variables. So one of these is the SSID. We set it to the in-house SSID. Then we need to specify the password. In our case, BlueCreation. I also wanted to auto-connect after a reset, so I set this option to true. And then, as always, we want to save this. So once saved, now we can again do a reset of the module, and we can see that it is now connecting to an access point. So in a few seconds it should be connected, and we can proceed with the next step. Now for the next step we need a TCP server running on our PC, and for this test we're using the Hercules setup utility because it has a easy to use integrated TCP server. So we go to the TCP server tab, we select the port number, in our case 4444, and we press listen. Now we have a server running on our PC, and all we need is find its IP address so that we can connect to it from our module. In order to do that, we can press the Windows key and R, which pops up this dialog. We type CMD, and we get a screen which allows us to type commands, and the proper command for this is ipconfig. So once we type the command, we can find our primary interface, in our case the Ethernet cable, and find its IP, and in our case this is 192.168.120. So now we can proceed to connect to this address and this port number from the module. I have the command ready, and it is this command: Wi-Fi TCP client connect, and it takes the IP address, colon, and the port number I'd like to connect to. Now before I do that, I also want to set up logging on Hercules. So I can say log to file, and I can select a log file on my desktop, and then I can just enable this logging. And as we see right now, there is no connection and there is no data being transferred, so we're sitting at 0 transferred bytes. So on our module side we're connected, and to the access point Now we want to connect to our PC. So we send the Wi-Fi TCP client connect command. And we can see that the module said connecting and connected successfully. And also on our Hercules we can see that there is one new client connected. So now we can type any text we want in this window, and if we send it, we can see that now it has been logged to this file. So as many bytes as we send, they're being sent in real time to our PC. So this is alright, but we need to test the highest throughput possible. In order to do that, we developed a sample application which just pushes data through the UART as fast as possible using packet sizes of randomly generated data, which we then record to this file, and we can verify its integrity and the speed of transfer. So in order to do that, we have to close this COM port so that our program can use it, and then we just start it. Sorry, that's the wrong one. It's the loopback.xm, which is this one. And as we see, once started, it starts to measure the throughput it can operate on. And in our case, this is right now hovering at about 1.2 megabit per second, and the log file is being filled with the data at that rate. Of course, this number is highly dependent on the access point we use, so if you have a higher throughput access point, you might get up to 1.6 megabit per second, which is a theoretical limit of the UART interface. So if we're happy with this measurement, we can close this application and then stop logging to the file. And now we can just open the file to see if the data has been transferred correctly. So let's do that. Go to the desktop, and this is a tcp.log. And if we move it over, we see the first few bytes that we sent manually, and then all the data that we sent automated. So now we can, it's a pretty big file, but we can, if we scroll down, we can see that all the data is intact and nicely arranged. So this was a demo of achieving the maximal throughput on BC188. Thank you for watching.